Welcome back. This is Verb. Hey, call me or text me. Prefer you text me first. Tell me who you are. If you need any extensions or any extra help, it is that time of year. All right. Keep looking at your Google Doc. Google Doc being updated as we speak. Should have everything posted. And then by the end of today, which is I don't know, Saturday the 16th, 17th. Not sure what day it is actually. Maybe my computer will tell me. Um, it is Sunday the 18th. All right, so here we go, everybody. Vectors. Okay, so back to the first day of class. So let's look at a circle. And there's some point xy on the circle where this is x and this is y. And it was obvious that x squared plus y squared equals r squared. Or in other words, r is plus or minus the square root of x squared plus y squared. But you can't have a negative distance. So we have this radius r, and this was a 90-degree triangle. Then we proceeded to make up relationships. Sine of theta, let's call it y over r. Cosine theta, x over r. Tangent theta, y over x. And of course the three reciprocal identities, cosecant, secant, cotangent, but we're not going to write those down for today. Now, vectors, basically, it is plotting a point that every time you're plotting a point, you're considering the radius and the angle theta. So bottom line, trig is live when you're plotting vectors. Or vectors is the study in 2 dimensions using 4 variables, x, y, r, and theta. Now, we know sine of theta is y over r, but when you're in vector land, you say y equals r sine theta. And you say x equals r cosine theta. And here's the weird one. You always know what quadrant you're in when you're working with vectors, or just about always. So what we're going to do is inverse tangent both sides, but we're going to say the reference angle is inverse tangent, and I never take inverse of a negative because I'm the one using the inverse, so I can do what I want. I always just find the reference angle, the angle in the first quadrant, and then since I know what quadrant I'm in, I can just easily figure out using reference angle. Now, the only thing weird is r is called the magnitude of the vector, which is the square root of x squared plus y squared. What is v? Well, v is basically, looks like a point, 3, 4. In math notation, that is. In science or physics, they go 3i plus 4j, which I have to explain, and they put the little vector symbol over the top. But for right now, this is x, and this is y. So yeah, we are plotting the point 3, 4. But we're doing more than that. We're considering the vector 3, 4, which originates at the origin, and it goes from head to tail. Now we all know that this length is 5, and this is the radius of the circle, but you don't get to call it the radius anymore. Yes, it is the radius, but you have to call it the magnitude of v. So what's the magnitude of v? It's just the radius. So should we call it the radius, or should we call it the magnitude of v? Trust me, it's way easier to call it the radius, and anytime we ask for the magnitude, you just write the radius down. Anyway, this 3i stuff, this is the vector 1, 0 plus the vector 0, 1. So it's kind of weird to explain right here and now that here's this vector, and if you got 3 of them, there's 3, and here's the vector 0, 1, and then there's another one, and another one. Now, when you add vectors, the diagonal coming from the origin across this rectangle I construct is called, technically it's called the resultant. But when you add these, oh man, that's hard to explain what it is. I don't think I've ever put myself in this situation before. So I'm going to do another problem. Hopefully I explain it better. But do check out the algebra, because this is 3 comma 0. And this is, you just multiply it in, 0 comma 4. And then when you add vectors, you just go 3 plus 0, 4 plus 0. So vector algebra is actually fun. But sorry for the explanation there with the IJ stuff. I think I can do better, maybe not. I never use it. You know why? Because I'm predominantly, even though I'm a physics major, I do math, so I use the good notation. I don't like IJ. When you give me IJ, I'm converting it right to, it's almost like a point notation. So I apologize, almost. That was pretty funny. Anyway, let's just go right to example. So we got this vector u to be 3, negative 2. Let's find everything out about it. So picture-wise, it's over 3 down 2. And that is the vector 3, negative 2. That is the vector 3i minus 2j. Get used to your physics class. I know where it's located. It's in the 4th quadrant. I know the magnitude of u is just the square root of x squared plus y squared, because that's the formula for the radius. So the magnitude of the vector, which is the length, is the square root of 13 on that imaginary circle. What is the trig angle? The trig angle, first you got to find theta ref, is inverse tangent, absolute value of y over x, which is inverse tangent of 2/3. Inverse tangent 2 divided by 3. That would be better if you went divided by 3. If it's in degrees, you get degree answer. If it's in radians, you get a radian answer. And I just got a degree answer. So 33.690. That's my reference angle. Therefore, this is 33.690. Therefore, my trig answer, theta trig, is 360 minus the last answer. And I get 326.309 degrees. Now, there's other ways to say it. You could say true bearing angle just comes off the north. Oops, I was trying to do a different color. So theta bare, just straight off the north, measuring clockwise, is 90 plus that 33.690, which is 123.6900673, looking at my calculator. You can do weird things like calculate this angle here. So 90 minus and I get 56 point. So you could say south 56.309 east. That's another bearing direction angle, whatever you want to call it. But coming off the south, go 56.309 east. So theta bare comes right off the north. I like bearing angles. I like trig angles. I just think this is dumb because it's like so obvious that a kindergartner can figure that out. Just got to know your north, south, east, and west. And there's something about some stupid L thing that you can do with your hand if you don't know your north from your south, your all that stuff. All right, let's get busy. Okay, what else can we do? Oh, this is really cool. So you got some vector, um, and I give you, oh, say, so example. I give you theta is 150, and I give you the magnitude of V is 6. You give me the vector. Well, guess what? X is r cosine theta. Y is r sine theta since the beginning of the semester. So remember, r is the magnitude, so it's just 6 cosine 150, 6 sine 150. Which is, if you're a master of the unit circle, cosine is negative in the second quadrant, and that'd be the square root of 3 over 2. And sine of 150 is positive, and that's like sine of 30. And then I get negative 3 radical 3 and 3, which if you turn and burn your 150 degrees and measure 1, 2, 3, 4, 5, 6, this point is negative 3 root 3 and 3. Next, let's look at another example. Let's look at the vector 3, 4, and let's look at the vector negative 5, 12. And let's call this V, and let's call this U. So the magnitude of vector V is the square root of 3 squared plus 4 squared, which is the square root of 25, which is 5. The magnitude of U is the square root of negative 5 squared plus 12 squared is square root of 169, which is 13. I know vector U, or hold it, let me take a look. Vector V is 3, 4. Then we plot vector negative 5, 5, 6, 7, 8, 9, 10, 12. So that's vector 3, 4. And what I want to do is add the vectors. Now the cool thing about adding vectors, you just add the x components and you add the y components, and you get the point negative 216. So 13, 14, 15, 16, negative 2, and that's the what we call the resultant vector. Now, what makes this a very nice process is if I start here and I plot the vector 3, 4 over 3 up 4, I end up right there. Or if I start here and plot the vector negative 5, 12, I end up right here. So there's two ways to talk about this. If you plot this vector from head to tail, and then reset your axis, and then plot the next vector, you end up in the spot. Or if you draw the original vector and this vector, and then you set this at the head, or excuse me, at the tail, and you go over 3 up 4, you end up in that spot. So one method is called head to tail, and here's head to tail again. And the other method is called the parallelogram method, where you just draw the diagonal of the associated parallelogram. But note, this is vector V, this is vector U, this is vector R standing for the result. So V plus U equals the resultant vector R. Now, I know all the angles. You know what I mean? I know, for example, vector v, inverse tangent of the absolute value of 4/3, which is just 4/3. We know vector v lies in the first, inverse tangent of 4 divided by 3, 53.130. And I know vector u, you do inverse tangent of 12/5, and you pick up an angle, a reference angle of 67.380, therefore 180 minus the last answer, theta sub u is 112.619, and theta sub v was 53.130. And we can do theta r. It's just inverse tangent of 16/2. Once again, don't use the negative. Inverse tangent of 8. Pizza's done. 82, but that's a reference angle. You know you're in quadrant 3. So you go 180 minus the last answer, and we pick up 97.125 degrees. So we know a little bit of everything. Now, the one I'm very interested in is this angle right here, theta between u, theta between u and v. Since you know this angle is 67 and you know this angle is 53, you could just add them up and subtract from 180 and you could find that. But we're in luck. There's a formula that speeds things up, and it's called, well, here I know what the formula is. So theta is inverse cosine of u dot v over the magnitude of u, magnitude of v. But to do that, I need to tell you or explain what the dot means. How do you multiply vectors? So vector u is xy, and vector v is ab. Then u dot v is just the number ax plus by. It's a number. It's not a vector. So if I give you vector u to be negative 12, 5 dot vector 3, 4, it is negative 36 plus 20, negative 16. And therefore theta is inverse cosine of negative 16 over the magnitude of u, which was 13, and the magnitude of v, which is 5. So it's inverse cosine of negative 16 over 65. Do not get rid of the negative because the formula has the inverse in it. So just type it in. Whoa. Inverse cosine, negative 16 divided by 65. And we pick up 104.2500327 degrees. Now, I need to verify. So we can go 180, take away that 67.380.380, take away the 53.130, and we get 59.49. What went wrong? 59.49. So up above it says theta between is 59.49. What just happened? Mode degrees, inverse magnitude of u, magnitude of v. Ooh, 65. Double checking my calculation. Not exactly sure. Let me pause for a second. All right, found my error. As you guys probably already knew, screwed up this is -5, this is 12. Fix this right here, and we're going to be all good, because we get -15 plus 48 is 33 plus 33 and 33 and inverse cosine of 33 divided by 65 is 59.49 degrees. So check. I just copied the problem down wrong. It's the only mistake I really made, but there is a theta between formula, and it is nice to know. You don't need it, but especially in calculus 3, you'll want to know it. So it's angle between 0 and 180. So it's always, they're never asking, you never find this angle. You always find the smaller of the two angles using this formula. So that's just for starters. There's so much to this section. So if somebody just says 5, 3, 6 minus 3, 2, 9, you can distribute 15, 30 minus 6, 27, which is 11, 3. So vectors have great properties. And let me see if I can explain this. So if you got a vector x1, y1, and you got a vector x2, y2, that x equals r1 cosine theta 1, and y equals r1 sine theta 1, and x2 is r2 cosine theta 2, and y2 is r2 sine theta 2, then r1 cosine theta 1 plus r2 cosine theta 2, and then we get r1 sine theta 1 plus r2 sine theta 2 gets us to the resultant vector also. So I don't have to be given just x1 and y1. I can be given r1 and theta 1. And there we go. And if I give you r2 and theta 2, I can get to the result. Now, I will tell you that when you are adding two vectors, law of sines and law of cosines can come into play. I guess the best way to explain this is to actually do a real standard example. So, if you have a plane traveling, let's keep it pretty good. Let's pretend we're traveling at a 30-degree angle. Or off the north, they say theta bar is 60, but theta trig, you're traveling at a 30-degree angle. But if you're at, you use bearing angles when you're flying. So, there's trig angles off this x plus axis. Bearing angles is how they give you flight directions. Anyway, let's say you're traveling at 300 miles per hour. So that could be called a velocity vector. But what is happening is there's another vector, a wind, coming in at 45 degrees, or there's a wind with theta bar at, 90 and 45, 135 degree wind. The wind is coming from this direction, blowing this direction. So what is happening is you reset this, and you're there, because it's at that direction, and your result is going to be here. Now, the idea is to solve this triangle, but it takes a little bit of effort here to figure things out. So when you're here, it's almost like we got to zoom in on this, and sometimes even I'm a little slow here. We can finish our parallelogram if you want. But I'm going to tell you that this length is, let's say, 25 miles per hour. And we know the direction. We know that this angle right in here is 45 degrees. Okay, so we know this angle is 30. Do we know another angle is 30? Well, this one would be 30. Not that that helps us any. We got to be smarter. Oh, here we go. This is 30. Oh, if this is 30 and this is 45, we know this is 105. Oh, look, we got a side, we got an angle, and we got a side. That is law of cosines. And then via law of cosines, we know we can find the resultant length, but we know we can also find this angle here, which in turn helps us find this angle here. Because we know this one's 30, and we find this, we can actually subtract it. So using law of cosines, we can basically tell you where you end up, which is the red vector here. It's going to take a while, but since you got, okay, let's go V plane, is, well, it's the magnitude, which is 300, cosine of 30, and 300 sine 30, plus V wind, which is 25 cosine. You got to use a trig angle, and that trig angle is 135 degrees. 25 sine 135. Keep in mind, all I'm really doing is first day of school, first day of class, r cosine theta, y equals r sine theta. So if I give you the radius or the magnitude, and I give you the radius and the magnitude and the angles, you know your x's and y's. Laws of vectors say just add them. So you get 300 cos 30 plus 25 cos 135 is 300 sine 30 plus 25 sine 135. All right, so we get our calculator out. All right, go over there if you want. Okay, on 300 cosine 30 plus 25 cosine 135. And I get 242.129. Let's stow that in A. Stow alpha A. Then let's scooch up and then switch the cosines to sines. And we get 167.677. Let's stow that in B. So, don't know if you realize it or not, but we just found this point right here. We found that to be, this is 242.13, and this number is 167.67. Now you could use the Pythagorean theorem to find this length, but it doesn't matter because laws of vectors, we call this the resultant vector. And if you want to find the magnitude of the resultant vector, the magnitude is just the radius, and it's the square root of x squared plus y squared. It's the square root alpha a squared plus alpha b squared. Oh, here we go again. Okay, I've been here before. Alpha b squared. 294.521 is the new speed. The plane was basically, is that true? Slowed down? Let me see. 242, 167. Make sure I did my math right. I'm gonna have to double check things, but yeah, let me do that first. Pause. Looks like we're all good there. So if you want to find theta sub r, it's just inverse tangent. You know you're in first quadrant, and A and B are both positive, so just do inverse tangent of B over A because you do y over x. Second quit, clear. Inverse tangent, alpha B divided by alpha A, and we end up at 34.703 degrees, which puts me in the wrong direction. So I have to see what's wrong because it says my course is actually 4 degrees above what I took off. Therefore, there's a small mistake somewhere, and we need to find it. So, sorry guys, I found out the whole problem. This is 315 degrees. It's not 135. That was dumb. So these 135s are just 315s. And then everything's going to work out right. That was just dumb. So I'm going to go through, fix them all, redo my problem. I should just re-record this, but it is what it is. 315. So we get on the calculator, and then we go grab some calculations. Let's go grab that cosine one, and let's change that to 315. 277.48. Stow alpha A. Stow alpha A. Delete, delete. Stow. Delete. Let's just try it. Stow alpha A. Stow. There we go. Alpha A. And then let's bring this back up. Switch these to sines. Sine. sine 132.32. So alpha b. And then we go look for the square root of alpha a squared plus alpha b squared. And there we go, 307.420. And then you go look for that inverse tangent of b over a. There we go. Everything's better now. Terrible presentation, but managed to fix it all. Here's the deal. I knew where I was. I knew I was less than 30. I knew my magnitude was over 300 because the wind was behind it. Should be going faster. So, sorry about the mistake. To work this problem, I just bypassed law of cosines. I love using law of cosines and law of sines, but vector algebra can help you avoid law of sines, law of cosines. I'm not saying it's the best way to do it all the time. I'm just saying I love vector algebra, I love law of sines, I love law of cosines. If I can mix them all together, I'm a happy guy. I do like vector algebra because it's a very systematic process. By the way, a lot of people aren't very good at it. I really don't understand why. It's just, adding's great. There's a magnitude definition, there's an angle definition, and it's just good math. To work these airplane problems, there's these certain words you got to know. There's airspeed, there's ground speed. And then there's wind speed. And then there's the air, and there's the ground, and there's the wind. So if you got a plane just set at this angle, just takes off, which a plane wouldn't normally do that, that would be theta air. And then a wind blows on it in a certain direction. But you got to understand, that's not actually a vector. This is the vector. And this is the angle that we're talking about. And it's going to put you here, and that is the ground. This is the air, and that's the wind. So V air plus V wind equals V ground. And this is the resultant vector. So that way, when they're giving you all these problems, you won't get all messed up when they're phrasing them. So let me try this. A plane with airspeed, so the magnitude of V air, that's airspeed is the magnitude of the vector, is 192 miles per hour. Bearing, theta bear, is 121, which means nothing to me because I need to figure out what that really is. It's 31 degrees past, so the true angle, theta trig, for the air is actually, well, that's 31, so 329. 31 would hit you there. So Next, a north wind blowing. Uh-oh. So you got a north wind. A north wind is blowing from north to south. So wind going this way. At 15.9 miles per. Oh, so here you go. The world's simplest vector. I hate it when they do this. Why do they give me that one? That I know the angle. It's 270 degrees. So let me go back to my picture. And then there's this. And then there's this. And then there's this. So the red is V ground. And that's what we're going to try to find out. The magnitude of the wind, they tell me, is 15.9 miles per hour. Theta wind is 270 degrees. See? 270. So, if you want to solve this, just remember the air plus the wind equals the ground. The air, well, you don't need your x and y, you just need your magnitude and your angle. So it's 192 with the 329s. So 192 cosine 329 plus 15.9 cosine 270, 192 sine 329 plus 192 sine of 270 gives you 192 cosine 329 plus 15.9 cosine 270 stow alpha A 164.576 and change these to sines. Sine. Okay, I'm in the fourth quadrant, which I totally thought I was. Now, you're in the fourth quadrant, that theta ref is inverse tangent absolute value of y over x. So theta ref equals inverse tangent math num absolute value of alpha. I didn't store in B. I got this. Alpha B divided by alpha A. Get it wrong. Go up. Evaluate that. Stow alpha B. Now go reevaluate. There we go. 34.894, which is my reference angle. So the true angle, theta trig, is 360 minus last answer. So theta trig is 325.105, but theta bare for the ground is 90 plus 34, 124.894 degrees. The magnitude is the square root of alpha A squared. There we go again. How about try this from scratch? The square root alpha A squared, alpha A squared plus alpha B squared. So the magnitude of V ground, the square root of A squared plus B squared, 200.652 miles per hour. All right, that's long enough. I hit the 45-minute mark. Most likely I'm gonna be working problems anyway. If I got time, I'll do another lecture and do second one, but this one covers the basics. Should be able to get your MML started. See you later. Bye.